Everyone, it's David Bombal coming to you from the sunny island of Lanzarote off the coast of Africa. Once again, talking to my good friend Hank Preston, who I believe is not experiencing the same kind of weather. But Hank, it's great to talk to you.
You too. I am super jealous. I'm coming to you from my normal location of the Midwest in the U.S. in a land known as Ohio, and we are currently overcast and raining. Although the temperature's up, we broached 60, but that's Fahrenheit, so I have no idea what that is in Celsius for the rest of the world. But we're starting to get into spring, so it's a bit warmer today.
That's good. So no snow on the ground, is there?
No, we haven't had snow for a bit, though this is the first morning my son was allowed to wear not his big winter jacket to school. He got to put on a light one, so that was his little bonus for the day.
That's great. I mean, Hank, actually, before we started recording, you mentioned something, and I think it's important for everyone to know about this. I asked Hank, I suggested to him that I need to get him a nickname like the code boss or something, but he's actually been called better names than that. So, Hank, you've got to show us the sticker. You've got to tell us about, how did you get this nickname?
Yeah, absolutely. So it's funny, and so I do a lot of WebExes all over the place, and I was on a WebEx once. It was an internal WebEx with a bunch of people I knew, so it was a friendly audience, and I was going through the question and answers that came in through the WebEx afterwards, and I had noticed somebody was making a joke that I looked like Chris Pratt. And Chris Pratt plays Star-Lord in the Guardians of the Galaxy movie, and I think it was right around the time the first one had come out, and I laughed it off, and I was like, yeah, that's funny. I'll take the compliment. But then it happened several times. For some reason, people are like, hey, you look like Chris Pratt. I think it's the facial hair, maybe, more than anything else. But because it happened often enough, I was like, you know what, I'm going to own it. I will go for that. And so one of the guys I know here at Cisco, he does all the cartoon work. If you've seen me do Carl or Captain Cloud or Donkey Kong. Yeah. And so I sent him a picture of Star-Lord from the Guardians of the Galaxy movie, and then a picture of me, and I said, hey, can you merge these together? And so he came up with, let me see if I can get this in front of the camera, he came up with Code Lord. And so I've done a handful of stickers for it and go through on that. And I'm happy to say that, you know what, if I have to have a nickname, there are worse ones to be called than Code Lord there. So
yeah, definitely. You'll have to send me one of those, or when I see you at Cisco Live in June,
Absolutely.
Give me one. Definitely want one of those.
Yeah,
so,
it seems a bit self-aggrandizing to give them out all over the place. So I haven't made like hundreds of them to give out, but I've got a few, so I'll bring some with me and for sure can give you a couple of those.
So everyone watching, if you want one of those, Hank, I think we're going to have like a storm of requests. If you want one of them, put a comment below the video, and then you can have your own stick of Hank Preston. I mean, Hank, I just want to say thanks so much for sharing your knowledge, man. So it's really kind of you to share this stuff.
Yeah, absolutely. It's good. And if folks want them, I'm certainly willing to give them out. It's just I try to be somewhat modest because I just can't believe folks are that interested in what I have to say sometimes. So.
No, definitely. I mean, what you're sharing is so valuable. So I really appreciate it. So Hank, before I go on too long, you mentioned that the topic for today was something about a genie in a bottle or something along those lines. So you got to tell us, what's this about and how does it help us in the real world with network automation?
Absolutely. So the tool we're going to talk about today is a new element to a tool that Cisco launched completely for free. I think it went public at least a year and a half ago at this point. And it's part of a package called pyATS, which is the Python automated testing system. And it's a tool that was originally designed inside of Cisco for our business units to test the OSs. So when they were writing changes and releases for iOS or iOS XE or NXOS and iOS XR, the software developers writing features like OSPF or BGP needed a way to make sure that those software features were working correctly as they were doing revisions for the operating system updates. So it developed in-house for that purpose. And then there was enough interest from community, our customers, that wanted a way to test their own networks were working the way that they wanted it, that we released the pyATS framework completely for free. It's up on Python. Pip install pyATS will get you started as far as that goes. And you can build tests for, is my network functioning? So you can learn all about your routing protocols or your interfaces and just make sure they're working. And part of the pyATS framework is a component called Genie. And the idea behind the name is Genie is just freaking magic. what it gives you, the power that Genie offers the network tester in a very easy fashion really is just downright magical sometimes, is what it feels like. And so that's where the name came from, is it's network magic as it goes in. What's interesting for me, or what got me so excited over the last couple of weeks that I dove in really hard, is that as a testing framework, Python or pyATS and even Genie, always you needed to know a little bit about programming and automation and how to write tests effectively to really take good advantage of it. There were some samples and examples, and we had plenty of demos and pieces where you could get in pretty quickly, but you still needed to understand a little bit that was there. In the most recent release of the tools, they added a component called Genie CLI to completely remove the barrier of any kind of programming knowledge or logic or comp sci skills or even testing skills to take advantage of the power that the Genie offers us to learn and compare and understand our network better. And so that's what we're going to talk about today, is a tool that is really sophisticated in what it can do, but the ability to use it, any barriers, any like you must know this first, has all been removed, and it's down to some very simple CLI commands that you would run on your laptop or your workstation against your network environment, and just take it from there. And it's really quite impressive. And my goal, and I told David this before we started the recording, my goal is that David and everybody else watching the video comes out of the other side feeling that Genie is a little bit magic as well as it goes through. So questions on the layup? Have I sold it too hard at this point?
Oh, you've set yourself up for like a really big task to convince us that it's as easy as you make it sound. But knowing you, that's going to be true. So Hank, before we get to that, can you tell us a little bit about your YouTube channel? Because I think you've discussed pyATS on that channel.
I did. So I put up videos, obviously with you, David, and I love doing these videos every week, and it's a highlight of my Friday to start out this way. But I've also do videos for DevNet, and there's a bunch of them that are there. But I do have a tiny little corner of YouTube that's my own that I post typically lately under Net DevOps Studios is the playlist and kind of the idea that I have. And I post videos there that the goal for them is that they're just short snippets that kind of highlight something that I personally find really helpful or interesting, some cool tools that I discovered, some idea that's in there as it goes through. And so you can check out my videos there as well. And so I recently did a kind of a full-on demo of some of this Genie CLI pieces there as well that we're going to hit here. But I love talking about it often enough that I don't think there can be enough videos. So.
Yeah, I mean, you discussed pyATS on, I'm not sure if it's that channel or another channel of yours, but I'm not sure if we're going to have time to discuss pyATS in a lot of detail. So I'll put the links below the video if anyone wants to see more of Hank's videos on the YouTube channels. Sorry, Hank, go on.
Absolutely. Oh, no, absolutely. I think what you might be thinking of, too, is the Net DevOps Live weekly webinar show that I host. Yeah. We actually kick that off as far as when we're recording, it's next week. Who knows when this it'll actually go. But April 2nd is our first one of those. And I'm doing a session, an hour webinar, which will then be recorded and edited and posted to YouTube on important Python tools and techniques for network engineers to go through. So we're going to talk a bit about things that as you kind of start to do more coding, best practices, concepts that, because most of us didn't come out of kind of computer science backgrounds, we just hack together scripts as we go through. So just little fundamental pieces that, in my opinion, can help our code look better, make it easier for other people to use our code, make it more robust as it goes through. And so that series, we kick off with season 2 on April 2nd, and then that'll run all the way through It'll run all the way through June, season 2. We got 13 episodes, and then we'll take a bit of a break, and we'll be back with season 3 with a new lineup. So
just for everyone's benefit, I mean, if you want more information than what you're getting on my YouTube channel, have a look at Hank's channels for extra content. So, yeah, I'll put the links below, Hank. Hank, I'm going to shut up now and hand it over to you. Show us this amazing tool and convince us that it's something we want to know about.
Absolutely. All right. So on the screen, what we've got here is I've got, as typical, my terminal window. So this is off my own workstation. And then I've got my editor that's over here. And we've talked before. I use Atom as my code editor, but any editors is just as good as any of them. And so we'll do what I normally do is just kind of show it working, and then we'll kind of talk a bit about how it goes through. And so as I mentioned, it's a CLI tool. So Genie, and I'll do -- help. So it's driven to work and feel like a CLI tool. And we can see in here it's Genie and then commands and then options, which is fairly typical. The commands that Genie knows is diff, learn, parse, run, and then shell, though we really don't dive too much into these bottom three. We're going to stick with diff, learn, and parse. That's where we can get a lot of the benefit of what we're after. And so I'm going to start out with Genie learn. And so we're going to say Genie learn. And Genie can learn a lot of things about our network. We're going to kind of hone in on just some basic pieces, and then we'll grow from there. But we'll say Genie learn interface, right? So network devices have interfaces. So let's learn about the interfaces. Now we have to tell Genie where our network is, and we do that with something that's called a testbed file. And so -- testbed, I have to tell Genie where the testbed file is. I have it here in the same directory, so it's called testbed.yaml. We'll look at that file in a second. And then I can tell it which devices. By default, Genie's going to look at all the devices that my testbed has in there. But for now, for this first demo, I'm just going to hone in on just one. So I'm going to say device, and we'll say iOS XE. So I have an iOS XE device in my network. And then I can, if I just hit enter now, anything it learns, it's just going to create the files and dump them in the local directory. I often say, you know, I want to store all these things that are learned in a different output directory. And so -- output. And I'm going to say put those into a directory we're going to just call learn. All right, so we're Genie learn. We're going to learn about the interface. Our testbed file is testbed.yaml. We're going to check out device iOS XE, and we're going to output what's learned to the learn directory. So my wrapping is always getting me here. So LEARN, learn. So I enter on that. And now, so the actual network that we're connecting to is as always, the DevNet always on sandboxes. And so I'm connecting to our iOS XE device that's sitting up in the internet and available kind of directly. That's through there. This one happens to, it's closer to you than it is to me. It's over in Galway, Ireland is where this data center is. And so some of this connectivity is just the fact that I'm using SSH across the internet through several layers of security pieces to go in. So when you're connecting, actually this 12 seconds is what that took. I was actually killing time thinking it was going to take longer, but 12 seconds to go through and learn about the network device to go through. And so we get a summary here. We have some log files that are created. So it connected to CSR1000V, that's the host name for the device. And so there's a log of the connections in learn connection underscore iOS XE. And then the feature, everything it learned about interface, I get 2 files for that. I get the ops structure. The ops structure is where the real magic comes in. It learned about the interfaces and then automatically created for me a JSON data structure. So it took everything about those interfaces and then put it into a JSON file for me. I didn't have to parse it. I didn't have to do like a text FSM manipulation. I didn't have to use regex. It just learned about the interfaces and created me a data structure. But if I was interested in the actual output that Genie used to create that, I actually get the raw console output as well. So those are the files that are there. And again, it put them all in that learn directory. So if I do ls-l and we just look in the learn directory, in fact, I have those 3 files: connection, console, and then ops. And if we look at those, we'll start with the more interesting one. So over here in Atom, I'm going to expand out my learn directory and then the ops file here. And I'm just going to tell Atom it's a JSON file. So this is what was learned. So just that simple command, right? Genie learn interface. This is the key bit of it, right? Genie learn interface. It connected to my network device and then created this JSON object that represents the interfaces. So we've got some pieces here at the top, and then we get into the info block, and we can see gigabit Ethernet 1. It's currently auto-negotiating. Its bandwidth is set to, it looks like a gigabit, if I'm counting the zeros correctly. I get all the counter information, so how much traffic is going through this interface as it goes through. I can see what the delay is currently set at, the description, duplex mode, enabled status, in-cap, flow control, IP address information, the MAC address, the MTU, Opper status, the FIS address, the MAC address. All that stuff is automatically learned about my device and put into this structure that I can use for anything that I want to, really. It's just a JSON data file. And so if I am experimenting in Python and doing stuff from there, I can now just read this file in and immediately have access to everything about my device in this automatically parsed framework for me. So this is the first bit of magic. How am I doing so far?
Yeah, that's great. I mean, I think just for everyone's benefit, I mean, to try and replicate that in raw Python is a lot of work.
Yes, it is. I think if you've ever ran, I mean, and we'll look in a second, the commands that were run for here, but right, show interfaces was run for part of this data. And then you get that raw blob of text. And then you've got to figure out how to find every bit of detail. And normally when I've had to do that in the past, there's one piece of information I'm interested in. And that's not so bad, right? You can find one piece of info. But to find the 50 or so characteristics about this interface and automatically make them all available at once, pretty stinking cool.
Yeah, I mean, and to put it in a YAML format, just again for everyone's benefit, YAML makes it a lot easier. I mean, I'll let you explain it, Hank, better than I do, but it's when you say structured data format, it means it's easier to work with in code rather than just a raw text file.
Exactly. So we can actually so YAML is what we're gonna see a YAML example when we look at the test bed. This one's JSON, and whether it's YAML, whether it's YAML or JSON or XML, the goal of all of those structured data formats is to make them really easy to work with in a programming fashion. So for example, I can simply go into, I can open up Python. So I'll just open up an interactive Python interpreter here, and then say import JSON. And so JSON is the Python library for working with JSON files. And then I can say, you know what, I want to open up and read this file. So I'm going to say file, we'll say JSON source equals open. And this file is in my learn directory. And then interface, I'm going to copy and paste because odds are good I'm going to typo something. So it is in, this is the file we want to open. All right, so now I have I've opened that file in Python, and then I can say I want to read the file. So we'll say JSON read equals JSON source dot. And so if you're not familiar with some of these Python pieces, what I did here is saying, okay, Python, go ahead, open up the file, give me access to the file, but it hasn't actually done anything with it. On an open file, you can read it in, and now I'm reading it into a new variable called read that'll be a string content of the file. So I'm just going to read that in. And so now if I print out JSON read, we see that it's the JSON. And this is just a string, so type of JSON read, it's a string. So this right now hasn't been parsed. But what I can do is say, okay, give me interfaces equals JSON.load s for load string. And so JSON read. And so now I'm saying, go ahead and take in the string JSON read, we just saw that, and then process that like it's a JSON object. And so process that. And so now when I look at type of interfaces, I have a Python dictionary. Now that it's a Python dictionary, I immediately can get access to all of this information that I wanted. And so I could say interfaces, and I'm looking at the keys over here. So this is what we just modeled inside of Python. And so for example, interfaces, and then we'll say info, because all the interfaces we can see are underneath this info key. And then I can say I'm interested in gigabit Ethernet 1. Right? And so now I've got gigabit Ethernet 1 here inside Python, and this is all the pieces. If I wanted the IPv4 address, it would be, looks like IPv4, and then IPv4 puts me here, right? And then we can see that there's a key that is the IP address that's there. So we can go, it would be, so in this case, I'm looking at this. So if I didn't know what the IP address was, I can just say .keys, which will tell me all the IP addresses that are there. So we can see that there's an IP address of 10.10.20. Now that I know that, I could say, okay, well, give me the details about that address, 10.10.20.48, and we do it in slash notation. And so now we can see all the pieces. So very simple to get access to that, because Genie took everything about the device and automatically converted it into a JSON object for me that I can work with. I didn't have to do that string manipulation that if you've worked with kind of any of that CLI interaction through something like a NetMiko or Paramiko or any of the other options, something has to do this parsing for us. And that's the magic that Genie is that it has all this knowledge built into it on how to convert these very simple and standard data models based on the output from interface in this case, but hundreds of different commands and features that are on the device. And we'll look at more of those as we kind of continue. Questions on this?
That's amazing, Hank, because I mean, I'm just trying to think to be able to do that the old-fashioned way, like with NetMiko. It's a lot of code, and I mean you did that literally in like a few commands. It's really impressive.
I'm on line 10 now. Granted, I did the Genie Learn before that. Yeah. Now the magic is we did Genie Learn through the CLI to create the JSON file, but Genie's just a Python piece like NetMiko. And so I could do the Genie Learn inside of Python if I wanted to. So I could do, and I don't know those commands is free, but it's something like import Genie. Oops. Genie should get it in, and then there would be a Genie.learn, and you would give it the testbed file on the device you're after. So I could have learned all of this through my Python script if I wanted to. But what's interesting, and we kind of jumped right into Python to talk a bit about the value of the JSON pieces. But we don't need to do this to get the value, right? So I'm going to actually pop back out and get us back to where I was at. So we've learned about our interfaces. We've stored those, and let's pretend we didn't go into Python for a second. And all we had done is we had learned the status of our interfaces. Make sense?
Yeah, that's great. I mean, I think, Hank, just to diverge again, like always, I think next week, if it's possible, can you spend a bit of time discussing, the different options and the different the value of different options for network automation? Because here we've got Genie, you've mentioned pyATS, I've heard of Nonia, I've heard of NetMiko, Paramiko. In the past there seemed to be very few libraries or very few options, and now there seem to be so many of them. So hopefully, I don't want to take us off on a tangent now, but could you perhaps next week discuss your preferences and what you'd recommend people use?
Sure. Yeah, we can definitely go through that. And there are tons, and every day there's more. And I'll at first start by saying I'm not an expert on all of them for sure. And there's probably some out there that I haven't run across yet. But we can certainly talk about them and kind of how I judge and make decisions for myself. So,
yeah, definitely. Right. You've got more experience than most of us. So, it's good to get your opinion about that. So yeah, let me keep quiet. We'll do that next week.
No problem. All right. So what we've done, so again, we've got our learn. We know everything about our interfaces, and we focused on Gigabit Ethernet 1, but here's the other one. So Gigabit Ethernet 2, we can see all of its information that's there, counters, we can see its configuration. It currently looks like does not have an IP address on it, nor does Gigabit Ethernet 3 doesn't have an IP address on it, and then we've got some loopbacks that are on, just one loopback it looks like. So that's the current state of the interfaces on the device. Now let's say we went through and some network changes happened. So I'm gonna do some network changes the old-fashioned way through CLI. So I'm gonna find my iOS XE CSR device here. I'll make this bigger. So I'm connecting to that same device we learned about, but now I'm doing it through regular good old-fashioned CLI and SSH. Getting my window adjusted here so that we can see it well. Okay. All right, so I'm on my CSR device, and so if I do my, it's running a bit slow today. Show IP interface brief. So we can see that again, no IP address on 2.3 and one loopback. So let's make some network changes here. So I'm going to do interface gig2, and we'll say IP address of, 172.16.34.23.255.255.255.0. And then we'll give it a description of demo, and then we'll also create another interface, a loopback interface loop. We'll say 101 IP address. Sounds like something, a little background noise, but hopefully it won't last long.
Yeah, don't worry.
192.168. We'll say 34.100, and we'll give this one a /32. Not enough numbers. There we go. All right, so I've added a couple of interfaces to the device. So we've done this out of ban. So now what I'm going to do is I'm going to go back to my Genie interface over here. And where's that learn command we did? It was up here. So there's that Genie learn. I'm going to output this to learn2. So I'm going to create a new folder called learn2, and we're going to relearn our interface status. So I'll run this again. So we can see, once again, we're learning interface on device iOS XE. And so this is doing it live. It's going to connect back to that device, and it's going to grab the pieces that are there and grab them all for us.
I think, Hank, once you've done this, I'm assuming you're going to do it at some point, but just to make sure, could you go again through those commands, like what Genie learn interface, what all of that means? Yeah.
Yep. We're going to go through. I'm going to show you the next piece of magic, which I think is, for me, the part that we actually will see the huge value that's here. And then we'll dissect everything it takes to make this work as it goes in.
Great.
Bit of shock and awe up front is my goal.
That's brilliant. I mean, I think if you haven't done it the hard way, you don't necessarily appreciate how powerful this is, because to just get the output, what you've done there is such hard work.
It's almost one of the, and I think that's the danger we're going to have as I try to get people excited about this, is if you haven't, to your point, done it the hard way, it's like, well, what's the big deal, right? You ran a command, you got some details. That's not so hard. I've run a show command 100 times. But it's that programmatic aspect as it goes through. All right, so we've learned it a second time. We can see now we've got this learn to folder. And so we get the same thing. It connected to the device, it ran a bunch of commands, and it processed it into a JSON file. Now, if we remember, we did Genie -- help, and so we just used Genie learn to learn device features and save it to a file. Now, we're going to use Genie Diff. And what it says here is command to diff to snapshot save to a file or directory, which is really understated. This is going to look at what was, I'm going to call, the first learn we did was our baseline, right? We baselined our network, what the interfaces are supposed to look like. Now, let's suppose somebody called in and said, hey, there's a problem on the network, right? I don't know what's going on. We've now relearned the current state. And so what Genie Diff lets me do is compare baseline to current. So Genie Diff, if I do -- help, so we've got help all the way along through the Genie CLI, we can get some really good help that's here. And the examples are this is as simple as it is. Genie Diff, file 1, file 2, or directory 1, directory 2. And then we can output this to a directory as well. So I'm going to do Genie Diff, and we're going to compare learn to learn to, right? So baseline to our what we just checked, and I'm going to output that to diff 1. So it's going to create any differences will be created in a directory that it's going to call diff 1. So we'll run this. This is super fast because it's all done just locally. It didn't even register as a second, you can see. And we can say, hey, the file interface iOSXE CSR 1000V ops, so that's that JSON body, that parsed, right? It says, hey, there were some differences. You can find those differences in this file, diff1, diff interfaces. So now, if I go and I open that file, this is what we get here. We get a diff file. So diffing two files is not unique to Genie, right? We've done this all over the place. You've got two pieces. There are hundreds of utilities that can do difference comparisons. Notepad++ can do it. That's a common one on Windows. Any programming tool can just do a diff. And when you do a diff, pluses indicate things that are in the second file that weren't in the first, and minuses indicate things that were in the first file but aren't in the second. And so right away, I get a snapshot of every difference between my baseline of my network and the current state. And so I can see that now my network now has this configuration in it. It has Gigabit Ethernet 2 with a description and an IPv4 address. That didn't exist before. I've got Gigabit Ethernet 2, right? This is what the some of the output looked like before. That's now missing because we've started to do some configuration on it. Loopback 101, completely newly created interface, right? So we've got all of this is all new to the file. Immediately jumps out with what's there. So the differences come in. So let's say we look at this and say, okay, that's all well and dandy, no problems there, but someone comes along and they change an IP address on something, right? So we'll do config t, interface, gig 2, and we'll change the IP. So IP address 172. We'll say someone was in here making some network changes and they made a mistake on the IP address someplace. So I'm going to go ahead and say 23. Did I get? That's not a real one. And then end. All right, so I just made a change to the piece. If you're watching me closely, maybe you noticed what the change was. But I'm going to go ahead and run my learn one more time. And now we're going to say learn 3. So I'm going to relearn the status of the piece. It'll create a new snapshot of my entire network.
So while we're waiting for that, Hank, just remind me again, this is a free tool that's available from Cisco, is that right? Cisco wrote this.
It is. It's internally developed from Cisco. It's in the process of being open sourced. A lot of the interesting parts of Genie and pyATS are already open source. But what it is as it was originally developed in house, it didn't have all of it couldn't fully be open sourced immediately because documentation and there's a bunch of stuff that goes into that. But the Genie, what's called the parsers that do all the magic and the models, a lot of that's already open source. And we'll probably have some time we can go and kind of poke at that, and I can show you where some of the code for these pieces are as well. But either way, the entire tool set is completely free, and it's Python, so it's all available up on PyPy. So pip install Genie is how you get started with this.
Oh, wow.
Mm-hmm. All right, we're letting learn.
It's really nice to see that Cisco, it's always been and I think we'll leave this again to our second call, but while we're waiting for that, in the beginning it felt like, okay, so network automation is important, but now I have to reinvent the wheel. But now Cisco have got these tools that basically make our lives a lot easier. So it's getting closer to sort of the ease of CLI that people are familiar with, but having the power of programming behind it. Well, so it seems.
Yeah, it is. I mean, that's the area, is trying to show that Cisco's been along for the networking journey for 30 years now. We've been around and kind of gone through. And there's no reason to think that Cisco doesn't have interest in continuing to be involved as networking makes this next transition into automation and programmability. So just because you're automating your network doesn't mean that Cisco doesn't want to help you do that in an efficient fashion and offer you tools and capabilities that are there. All right, so Learn 3 finished. So I've got my Learn 3. Let's go ahead and do a Genie. Oops. I'll up arrow so I don't have to type as much. So we're going to do diff this time, and we're going to say we're going to diff. Now Learn 2 will be our starting point to Learn 3, and we'll call this diff 2. So we're going to compare what just changed. So everything maybe was fine with Learn 2. Now we come in and something is gone wrong, and we want to say, well, what changed now? So again, we've got our diff file here, diff 2. Go over to diff 2, take a look at it. And this one I like, right? So Gigabit Ethernet 2, we've added some lines and we subtracted some lines, and they do look like they're a flop, right? We can see that we used to have an IP address that where the third octet was 34, now it's 234. And so honing in, and then we focused in on one device, but Genie Learn, if I didn't specify -- device here, it would learn across our entire environment. And so if you've got a huge network of dozens or hundreds of network elements that are in there, you can learn the status of your interfaces across that entire environment, give yourself a baseline, and then when something goes wrong, you just relearn that, save it as another state, use Genie Diff, and you'll immediately see highlighted every single difference from that piece that gets pulled out and done in this simple, really simple, easy to use fashion that goes through. And so this, for me, this was the part that was like wicked exciting, because these types of use cases come up daily for network engineers where we're like, everything was fine yesterday, it's not fine now, what's changed? And the piece to keep in mind too is the changes aren't always configuration. It's easy in a lab like this to simulate changes by changing the config. But let's say the change was a routing relationship with a provider, right? So you normally learn a certain set of routes from your provider. You don't have access to their config or anything that's on there. If you do a Genie Learn, you'll be able to see, hey, we used to have these routes, now we have these routes. And you can hone in on that. And that's not a config change. That's a state change. That's operational information, which is oftentimes harder to bring down, because we're pretty decent at looking at two configurations and finding differences. Finding differences in the output of the counters on an interface, or the output of the prefix learn table from BGP or OSPF, LSA databases, right? These are harder things for us to immediately kind of find the answers to. And Genie makes that really easy with learn and then diff.
Yes, I mean, just so that I understand right, you showed like learn interface, but there's something perhaps where you could do learn route or other pieces. Is that right?
Yeah, so let's look at all the things that Genie can learn for us. And so I started out again, let me go find where we were. So we were doing learn, and we're going to output the learn 4 now. So we learned interface. Now there are a series of keywords I can go through, but rather than do them one at a time, I'm just going to go through and say, you know what, learn all. Right? There's a special keyword called learn all, And I can say, go learn everything, Genie, learn everything you can about this device. And so I'll hit that and we'll let this run. This will take slightly longer than 12 seconds because we can see and hear all of the keywords, all of the network features that Genie knows how to learn on the device.
Oh, wow.
ACL, ARP table, BGP, .1x if you're doing that, FDB, HSRP, IGMP for multicast, interface, which is where we've been, lag configuration, Lisp, LLDP, multicast, MLD, MSDP, ND. I don't want to read them all. But you can see it's like 28 different network features, and these are core network functionality features. And in every release of Genie, they're adding additional models. That's what these are referred to as feature models. So the VLAN is a model. We're adding more models. We're adding more knowledge, more magic to Genie every time there's a release. And as I was playing with Genie last week, there was a couple of commands, a couple of these models that didn't work exactly as expected. I sent a note into the mailer. There's a mailer in places and said, hey, these didn't work exactly. This isn't a joke. Normally, you find something wrong with a Cisco product and you've got, 2-3 months maybe it's got to go through, if you're lucky. It was like an hour and a half later. They said, oh, we fixed it. We're going to release it on Monday.
Oh, wow.
And so the team that's behind this, they're really agile. They're driven by this software piece, and they're super passionate about network testing and making these pieces easy. And this stuff comes up all the time. While this runs, and like I said, it looks like if this is somewhere accurate, it's going to take about 5 minutes. And on a local network, if I was actually learning my network here where I was at, it's much faster, but it's that slow internet connected device on the other side of the Atlantic Ocean, which is most of this delay. But what we can do is we can actually go look at some of the documentation here. So if I switch over to Google Chrome, so we've been focusing in on models. And so what we can see here is this is the Genie docs, and these are stored up on DevNet, which is kind of where you would hopefully expect to find them. And we can see interface model, ARP model, BGP. So this is that same list of what we saw over here. And so I can actually go into any of these models and say, okay, show me some details about the interface model. I can see the documentation that's here. I can see some of the config, and you'll notice the little GitHub icon here, because these are indications that these are actually going to take you to the source code. And so if I wanted to see the operation implementation, so how do we actually learn about these? And I'm going to open that up, flip over here. We can see this is the actual open source code for the Genie model related to interface that's out there. And we can see that it's modeled for iOS, XE, XR, and XOS as it goes through. If I go into the iOS XE, I can go in here to interface.py, and we can see some of the code. This is the actual open source code that is the magic behind. This is where the power of Genie comes from. And these parts, all of this knowledge, all of this part is actually, this is the interesting stuff, and this is already open source that's out there. If I back up out of the interface folder here to ops, this is the source code. This is the open source code for all of those model features. And so if you wanted to see how some of these pieces work, right, all that stuff is put up here, and how to learn operational state for these features. Now, we're not going to go into it on the call today. We certainly can as we revisit these. But you'll also notice here, Genie has a config capability. We've been focusing on show and gathering status and learning about the environment. Genie, not through the CLI, at least yet, though it wouldn't surprise me if the development team starts to add it, Genie can actually take and configure the network as well by basically, instead of outputting a JSON object that represents what the current configuration is, you can actually go in and say, okay, this is the current config, you make some changes to it, and then Genie can take that and then implement that. We'll use the buzzword of intent. Right? We can implement that intended network configuration with Genie and make sure that applies as well. And so Genie has both sides: operational, a bunch of show commands; configuration, a bunch of config commands. All that's part of here. And again, completely free. Pip install Genie. You get all of these pieces as they come down.
Yeah, Hank, we definitely have to have that call next week, because now I'm getting, in the past there's no options. Now there's so many options. So it's going to be really good to hear your take on that. So just before while we're waiting still for that to complete, how do you get to this page? Is it on the main DevNet page, or?
Yeah. Oops.
I mean, I'll put the links below the video, but if someone wants to just get it.
No. So if we go to, I'm going to just start at the main DevNet page, because that's usually a good place to go off of. And so I'm going to try to make this so the page isn't formatted really wacky. All right. So here, if I go underneath technologies and then networking, we should find somewhere in here pyATS listed here under tools. And so you can see there's lots of tools, and there's tons of these we haven't even talked about on a call yet. But here's pyATS, and Genie's part of pyATS. And I actually want to get them to, I should probably have them change this to pyATS/Genie, because we're starting to talk a lot about the Genie name that's in there, particularly with the CLI. But we click on that. And this takes you to the pyATS and Genie main landing page on DevNet. You'll notice actually in here, it won in 2018, so just last year, a Cisco Pioneer Award. If you're not in Cisco, you don't understand what a big deal that is. There's only about 4 of these that are given out every year, and these are awards awarded to product teams and products that are just pushing the envelope of innovation and capabilities and opening up new areas. And so in 2018, they won the Pioneer Award because of all of the stuff, plus more of what we're talking about today. I'll brag for a bit. DevNet Sandbox, the team that I'm on, actually won the award. I believe it was 2017. We won a Pioneer Award for providing that free, easy-to-use access to all of the Cisco platforms out there. And so the Pioneer Awards in Cisco are pretty big. I'd have to dig it out. I actually have my Pioneer Award from the Sandbox over on my shelf over there. So super, super proud of those as they go. But here on the pyATS homepage, we can see that you can get a bunch of information. Raymond Hedinger, if you're in the Python community, maybe you've heard of Raymond before. He's actually a Python core developer as well as a Python instructor. I had the privilege, and I call it a privilege, of learning Python from Raymond himself. He teaches some Python classes here at Cisco. His company does that. And I got to spend a couple of weeks with him learning fundamentals of Python. And it was the best technical training class I'd ever been in. This guy literally wrote a lot of the features inside of Python that we use on a daily basis. And so he is a big name in the Python world. And he was impressed enough that he did a video kind of talking about the value that's there. You can see here's that episode we did in season 1. Kevin Corbin actually did it with me on pyATS. So lots of good stuff on pyATS in general. The docs page up here, so underneath docs is where you actually drive into the documentation for everything about pyATS and Genie. And so from here, what I was looking at was things like the Genie features and models. So if I click on that, that'll open up in another page here, another tab for us. A page, and you can dive into the model. This is the page we were just at, the Genie models. We're going to talk a bit about parsers in a second, and then Genie also has triggers and verifications. We'll save those for a future video because those are nearly as cool as well. But what we're going to focus in, we've talked about the models as it goes in, through there. Cool. We killed a ton of time there. Before we go into what was learned over here, questions on some of the docs and pieces, things that I might have skimmed over, David?
So my apologies, Hank. I had to move because my battery got flat and I don't have power outside there by the pool, it's disappointing because it would have been much nicer to stay out there. So I'm now in a boring room, but let's continue. So yeah, I mean, that looks great, Hank. I think I understood everything. I think the biggest concern I have is, there's so many frameworks now. Which one should we use? So that video next week is going to be really important.
Yeah, no, that'll be a good one as it goes through. So we did kill time, so the full learning process has completed, and so I'm going to scroll back up to what was learned, to where we went through here. So let me all right. So this is where we started, and so Genie's giving me a summary for each one of them, and so we outputted everything into the learn for directory, and so we'll see every feature that Genie learned about. There's both an ops version, which is that JSON version, and then there's the console output, which is the raw output. So we can see ACL, ARP, BGP. And so in some cases, we'll actually see in here, so could not learn feature .1x. And so instead of an ops file, we get a exception file, and then we get a message, feature not yet developed for this OS. And so if there is a feature that Genie doesn't currently know for that operating system, you'll get a message that says, hey, we don't know .1x on the CSR 1000V. And frankly, I don't know if the CSR 1000V does .1x. So yeah, not a huge surprise there. So we've got those. So if we go and we actually look at some of this output, I flip back over to Adam. And so we did what? Learn for. Now it's here. I'm gonna actually put it over here so it's easier to see. So if I do ls, we'll just do ls learn for. Here's all the files, right? Each one of those files across the features that were there. And so we'll grab one. We'll grab routing. Where is it? Routing ops. Here it is. Oop, there's actually not a lot of routing configured on it. That actually makes sense. It's a single device that doesn't have anything connected to it, so there really wouldn't be much to route about. Let me find something that actually would be in there. Oh, we'll look at the config. That's an easy one to go through. So config. So one of the things it does learn is the config. So it does a show run config, running config, and then parses it and turns the entire running config kind of into an object that you can read that's through there. So I'll shrink this down. We'll, once again, just so it colors a little better, we'll tell that this is JSON. And so this goes through and it parses the configuration that's out there. And so we can see some of the crypto bits. We can see here's the interface config block for Gigabit Ethernet 1, line by line that's there. And so we can see the pieces that are configured as it goes in. Turn this into a little JSON piece that we've got as it goes through. Let me see if I can find another one of these models that looks a bit interesting. Here's I got to fight with my little pop-outs. All right. So we've seen interface already. What is another one that's going to be something that's interesting? There won't be any VLAN. There won't be a lot of VRS. Not interesting either. There's got to be something else that's going to be ARP. There's got to be something in ARP, right? Yeah. Okay. So here, we'll look at the ARP output. So this is the ARP model. And so we can see that off of interface Gigabit Ethernet 1, IPv4, we've got some ARP neighbors. So we can see that there's this address. We can see the MAC addresses that are there. So we can very quickly get the ARP table off of this device as it goes in. Tons of really good detail as it goes through. I'm pulling those off. You know what I can do is I have some output from a more interesting network that has some more bits. Let me find that. So this is the routing operational model from a device that actually has routes that have been learned as they're going through. And so we can see in here, so we've got the VRF management interface. So it's got a management VRF that's out there that has a couple of routes that are in place. As it goes in, it's got a default. So here's the default VRF, so the main routing table that's there. And we can see that I've got a route for 10.0.0.0/29. It tells me the outgoing interface. It shows me the routes. It shows that this was a connected route that goes through. Go down, I've got another one. This is a local route, connected. I think that there's some OSPF in here if I scroll far. There we go. So here's an OSPF route as it comes in, that this is an E2, an external 2 route. So the entire routing table was processed and then turned into this JSON output to go through. And so if there was a routing change, we could do a diff and it would immediately highlight which routes either disappeared or came into the environment that weren't there from our baseline as it goes through. Make sense? Questions?
Yeah, so again, just to confirm, in other words, you can do or use Genie to connect to hundreds of devices or whatever, check the routing tables, and then do that again at a later point, and then do a diff on those to see which routes have been removed, which routes have been added. And then you could do something similar with an ARP cache or something like that as well. Is that right?
It is actually. And you know what? Let's look at one of those rather than just say it can, because that's actually the demo that I did before, and I can rerun that demo very quickly. I'm just going to get my cheat sheet open here.
Does it do MAC addresses as well, Hank? I can't remember now.
It's learning MAC addresses from all over the place. It's learning them from the MAC addresses that are in interfaces. It's learning them from MAC addresses that if there's the MAC address table, so the MAC address table dynamic, like it learns all of those as it goes through and it grabs them. Now that we've seen some of the basics that are out there, we'll run a demo across a full network and kind of see that in action as it goes through.
Right.
And so what I've got is okay. So I've just moved to a different directory, and this is my Genie, my larger Genie CLI demo. The topology we're looking at is actually one that I'm going to do open imaging tab. And here's the network topology we're working on. Make that a little bigger. So again, it's a much larger network topology. So it's kind of what I've got in here is this is supposed to represent kind of like a data center object. So access switches, distribution switches, kind of the core where routing happens, kind of a WAN point, and then I've got a branch over here with an ASA firewall, a layer 2 switch, and then a couple of servers. So a fairly typical, just basic type of a network.
Yeah.
It's configured for connectivity. So when things are functional, we can get from server 1 to server 2, server 1 to server 3, kind of all over the place. And we're set up so that we can go through and do that. So using Genie, I can learn the status of this network. I can when everything is functioning successfully. So I'm going to grab this command here, and we're going to run this. And so what you can see is that we're learning all. So this is going to learn everything about the environment. It's using a testbed file, and we've gone this far. We haven't even looked at it yet, but we will. We'll look at the testbed file to see kind of how we define what the network is. And then we're outputting this into a folder called tests and then normal. The idea is we're capturing a baseline. And so what we can see is we're learning all of these features, those same features we talked about, and we're learning it. I didn't specify -- device, right? So it's doing it across every device in the environment. So here's the full block. So switch 2, 5, router 1, switch 4, switch 3, router 2, switch 1. So not ordered in any sane way, but the entire network device. So all of the routers, all the switches are going to go ahead and get learned that are out there.
Yeah, I mean, like you said, I mean, if you can show us what the command is. So I'm assuming like that mock normal TB YAML file is where you've specified the hosts or the devices to connect to in your network.
Yep. Let's look at one of those, because this is because it's running against a large network. It's going to take a little bit longer to go through. So we'll let that process. And what I'll do is we'll look at the testbed file. So this is the testbed file that we're using for the always on sandboxes. And so it's a YAML file. And so it starts out with, and if you've not worked with YAML files before, it's a key value pair format that uses white space to indicate relationships. And so everything left aligned is kind of a top level object. So we've got a testbed as the top level object. I'm calling this testbed sandbox always on. So you could think about your testbed name might be production environment or data center or WAN, right? It's just the name of what devices are encompassed inside of this test. And then we have our devices. And so I've got a top level object here called devices, and then there are multiple devices in my environment. I have my CSR 1000V. Everything, you can see how these are all indented underneath the CSR 1000V. These are characteristics from that device. And so I give it an alias, a friendly name that I'm going to refer to it. So I'm just calling it iOS XE. Its OS is iOS XE. It's a virtual iOS device. Credentials. So I've got TACX credential. The TACX, the username is root. And then passwords, we can see I've got the TACX password. And I've commented it out because this device doesn't actually have an enable password configured. Once you log in with root, you just get put into the enable mode. So no password needed for that, but I've left it in there as kind of a placeholder. And then how do we connect to the device? This default class Unicon is referring to one of the components of the pyATS Genie stack that is the underlying brain power on how to actually connect to a device. So how do we connect to a device over SSH or Telnet or a terminal server or Netconf for other APIs? In this case, we're just connecting over SSH. We can see the protocol is SSH. But everything is just, we'll always kind of refer to this Unicon, which stands for Universal Connector. So this you'll see repeated in like every device because that's the connector we use. And so I've got SSH is what we're going to use. So again, we're just connecting with CLI. No fancy API needed. This will work across a variety of types of devices and versions. And then SSH happens to run on this device on port 8181. Scroll down, I get to my next device. This is our Nexus 9000V, always on Sandbox. I'm going to call it, alias again, NXOS. Its operating system is NXOS. The type of device is NXOS. And again, username, password. Now, I've got the username and password specified at each device layer, and that's because these devices have different credentials. If my entire environment used the same credentials, we could just specify that once as it goes through. But because they're different, they're specified on a device level. And so in addition to the iOS XE, the NXOS, we've also got our iOS XR device. And so this again it's actually a brand new, it was just launched this week. It's an iOS XR, always on Sandbox. And so you can reach it, we can see its address. Again, we're connecting over SSH, the credentials are listed there. And so this is the inventory file behind the scenes that you articulate. So you create this once, and then all your Genie Learn commands, you just refer back to that testbed file. And if you've got a lab testbed file and a production, or you've got building 1, building 2, you can create these testbed files in however you want to organize them. If you've experimented with something like Ansible and you've worked with inventory files, the Genie testbed files are like the Ansible inventory files. Same idea. The articulation, kind of the list of devices and all the important details on how to connect to those. Make sense?
Yeah, and Hank, I've got to mention this because I know someone's going to say this. You've got your passwords in clear text in this file. We know we're going to get that question, or someone's going to comment about that. So, is there a better way to do it?
There is. There's better ways to go through and do that. So all of our devices in the sandbox are intended for everybody to use them. And so I do sometimes have the luxury of just being able to say, I don't care who knows my passwords, because we want everybody to use them. There are definitely better ways to do that. There's a concept called, an often used way is something called environment variables. And so an environment variable is something on your local environment, in this case, like on your running workstation. Environment variables are just things that exist kind of in memory on your computer. And so often usernames, passwords, things like that will get set as environment variables on whatever your tool system is. And so it doesn't exist in clear text. And we would just say the syntax for something like that would be, it's something along the lines of like env, and then it's like password. So some keyword like this says, hey, go check the environment, get the password. I may not have this syntax completely right, but that general way is an often option for kind of doing those. There are also advanced techniques and other options where you can read credentials out of a secure system. So if you store those in like a vault inside of a tool like Netbox, or you're using Vault from HashiCorp or some other place where your credentials are stored, Genie and pyATS, it can go and read those out from one of those secure systems, use them on the fly, and then they would be kind of removed as they go through. But yeah, putting passwords in here for a production, terrible idea. I do have a bit of luxury because it's a lab where we want everybody to use our devices, and so it's pretty easy to run them through like that. Good question.
Oh, that's great.
Thank you.
Yeah, I know we're going to get that because it's something I always get asked whenever we demonstrate stuff like this. So that's great.
Me too.
I mean, just to we mentioned it on last week's call as well. You've got a video where you showed how to do better passwords. Is that right? So it's talking about it right now. You've done something like that already, I think.
It's actually coming up. I mentioned it last week. It's one of those, we mentioned at the beginning of the video, we've got season 2 of Net DevOps Live is starting next week. One of the videos in season 2, and it's a video I've been wanting to do for a while, so that's why I put it on the schedule, is on security practices. So while we're waiting for this piece to finish up over there, we can go in and take a look. We can see, here's the, let's see, did I type the URL right? I think I did. Yeah, I did. So here we can see the season 2 is going through. April 2nd, as I mentioned, we kick off next week with important Python skills and techniques for network engineers. We have 13 episodes. The episode I'm doing, where is it? On June 4th. So it's not for a while yet. It's out in June, but it's Automate Safely, Net DevOps Security Strategies. And so we're going to talk about a lot of things related to how do you actually do some of this secure. So password and user management is going to be a big part of that. Talking about securing management interfaces. And so most of us are used to doing like access lists attached to SSH and VTY lines. How do we extend that when we start doing automation pieces as we go through? That'll be part of what we talk about. Encryption protocols that are encrypted versus not encrypted, how that matters. So we're going to go through a lot of that stuff on this episode in June. So put a placeholder for that. And I will certainly continue to advertise for this. Registration for these don't open. They open 3 weeks before each episode. And so registration won't open until sometime in, I guess, mid-May for that particular episode.
So these are live, aren't they? But you record them and put them on YouTube, yeah?
Yeah, so every one of these are done live. So they're at 11 a.m. Eastern time here in the U.S. On that side. And then once they're recorded, these are all placeholders for upcoming episodes. If I scroll down to season 1, you'll see every episode from season 1, we capture, we edit them, and then we post them. And so we can see all of them from season 1. You can grab them from the site here, or you can go straight. They're posted up on YouTube. So if you just go to the DevNet YouTube channel, and there's a Net DevOps Live playlist, or I always like it, give me the clicks on my website here, driving traffic over to DevNet. You can watch them right from here as well. to go through. Every episode also has resources attached to them. So you can see view webinar resources from the episode, season 1's first episode. And so the slides from the presentation, sample code we referred to, relevant DevNet pages, learning labs that go along with the concepts, and then any sandboxes that would be useful or talked about in the episode. All that's kind of captured as part of the resources. Everything there is available for, at this point, forever. We don't plan to take any of it down. So once we do an episode, if you don't have a chance to catch it live, within a few days afterward is always my goal to get the videos edited and published here so that you can grab them on demand.
Oh, that's great. I mean, I'll put the links again below this video for anyone who wants to, get access to these. I think what's really nice is, I mean, you're sharing with me here, but I mean, there's a whole bunch of other resources available for free that people can use. So that's great.
Yeah, that's good. And so we've killed plenty of time. So the initial baseline of my entire environment ran, and it took it, I don't know, a good 7-8 minutes to go through. And that's when we find the file again. And that's because, I mean, it's a fairly large network we're talking about, and it learns about 28 different network features from each of these devices. But I've now captured my known good baseline. When I captured the normal topology, everything was working as expected. And so if we think about how we use this as part of our troubleshooting life, we get a ticket in. And so I've simulated some network problems, and we can use Genie, Learn, and Diff to find them. And so let's say that we've got a network issue. We've got a reported problem where server 1 down here, kind of in our data center, can't talk to server 3, which is up in the branch here. I think we've probably all seen tickets like this. We just got some network connectivity. Well, between server 1 and server 3, I mean, we've got many network devices. We're going across our simulated WAN. If you were doing this by hand, you'd probably start poking around, try to figure out where the issue is, verify the problems, things like that. But with Genie Learn and Genie Diff, we can do this a bit more intelligently. And so I've captured my baseline. What I'm going to do now is say, okay, let's use Genie Learn as part of our troubleshooting capabilities. And so I'm going to run another Genie Learn here. Now, what we're running is Genie Learn again. Now, I'm not doing all because that takes a while, and honestly, it would cheat a little bit in how you go through. I'm saying, I want to focus in. It's a connectivity issue, so learn interface status. So are any interfaces, have they changed? OSPF, that's our protocol. So go give me a current status of OSPF. And then routing, so overall routing status, and then VLANs, because this is both layer 2 and layer 3. I've got some switches, maybe some VLAN adjustments. So go learn that. And this time, the testbed file we're going against is actually a testbed where that broken network exists, which is why the testbed now is saying it's called mock break 5. It's because that's the testbed where I've actually broken this network to go through. And we're saving this output to this demo 1. This one should take much less time to run because it's only got to learn, it looks like, 4 features across those environments.
So Hank, I mean, you've demonstrating using this like for diffs and show commands. Do you see that? I mean, while we're waiting for that, do you see this as the main use of this Genie, or do you see it also for configuration? Because you mentioned that you can do configurations with this tool as well.
Yeah. So one of the things that we've been trying to work on a lot lately inside DevNet with a lot of the folks that I talk about is helping network engineers start their journey into network automation. And there's lots of analogies for it: beginner, intermediate, advanced. The kind of one that we're talking a bit about these days is that go-to of crawl, walk, run. And so don't jump right in. You need a way that you can get started easy and safely. And so if something goes wrong, it's not the end of the world. And so using Genie for learns and diffs and operational status, I think, is a great entry point in that crawl phase, which is why we're focusing on it today. Is I think it's an area that everybody can comfortably start using without a lot of fear, without a lot of kind of pre-knowledge. We've seen it's a CLI tool. Right? Make a YAML inventory file and then start learning about your network. Over time, as your skill set, as your comfort level with automation, and you progress from crawl to walk, and then later on to run, Genie moving into that configuration stage definitely is on the track as it goes through. And one of the other things that's inside Genie, which is definitely somewhere in the walk-run area, is Genie has a concept called triggers. And so one of the things that you can go through is we all build our network in a way that say, you know what, I built my network, my routing policy's there, It's stable. We're in good shape. But what happens if we have an issue, right? The BGP neighbors have to reconnect. We lose a WAN link, and our entire routing protocol has to repopulate itself. What would happen then? Sometimes we don't want to do that, or we don't have a really good, easy way to go through and do those, or we just cross our fingers and it never happens. Genie's concept of triggers can actually simulate. I'm not even going to say simulate. It will go into the network and it will trigger things like BGP resets or interface flaps. And so you could go through and say, okay, Genie, learn my current state, then trigger a BGP reset, and then go learn the state afterwards and compare, because that should be exactly the same, right? And if it doesn't, now we give a place where we can go through and say, well, why didn't BGP come back up the way it's supposed to? Or go flap an interface, and did spanning tree reconverge the way that we expected, or how did things go through? And so those are more advanced elements that are included inside of the tools, but as we've seen, you don't need to use those to get real value out of what's going through. Does that make sense, or does that seem too kind of like pie in the sky?
Well, I mean, if you're telling me it exists today, I'm really happy about that. It sounds really good, yeah. Yeah,
they're right here. So Genie triggers, and if I click on it, you can see these, oops, I went back. So there's all these, I don't even know how many, lots and lots of triggers for process changes, interface shuts. And so these are things that, again, I would never say do that day one. We got to work our way up to those. And so our relearn here finished, which is where I think everybody, and that's why I'm so excited about it and spending a bunch of time talking about it these last few weeks, is I think that this learn diff process that Genie offers is something that you can and should feel comfortable doing immediately, because in essence, all Genie's doing is running show commands and then processing them on your workstation and turning them into these objects. It's this safe thing. It's just a huge time saver is what we're after. So speaking of time save, so our learn of the issue is completed. So again, remember, server 1 can't talk to server 3. We just relearned a handful of process or features. We learned about our interfaces, we learned about OSPF, we learned about routing, we learned about VLAN. And so now we're in the diff phase, and we're in the investigation phase. And so the first thing we're going to run is let's go ahead and compare. So I'm going to run a Genie diff for us. And so we're diffing normal, so we're going to compare our baseline of normal to our broken environment, which is those two different tests. I'll run these. And so this will process, and we're going to see there's a lot of these things that pop up and say, you know what, the lag knowledge only exists in normal, because we didn't learn that feature in our investigation, which is fine. I actually find it's easier just to go and look at what was diffed rather than trying to process through that entire file piece that's there. And so diffs demo1, demo1.1. And so we can see across all of those features, interface, routing, VLAN, the differences popped up in the OSPF feature and the routing feature. And I'm like, well, that's pretty interesting. I've got connectivity issues, and I know that OSPF had a change and routing had a change. And so I can look at any of these. So I can say, let's take a look at diffs demo1.1. What do you want to look at, David? OSPF or routing?
Let's look at routing, actually.
All right. So we'll say we're going to look at diff, routing, and we'll pick on router 2. So when I look at the diff of router 2, immediately I can see these negatives, right? If I've got a connectivity issue and I start to see a route disappeared, that's probably a pretty good indication of some place to look. And so I know that my current state, I lost a route to 10.0.128.0/29. Now, as it's my network, I happen to know that subnet is the server 3 subnet. And I could put it on the drawing, I just didn't when I built the topology. So I can see immediately now, hey, I used to have a route to get to server 3 on router 2. Router 2 is this guy. So it's missing the route to server 3. I can say, well, let's go look at router 3. Is it missing the route? In fact, it is. So both of my core routers getting out of the environment no longer have a route to server 3. Well, that's a pretty good indication that there's of a configuration problem for my topology that goes through. And if I could continue to look at these other ones, if I look at router 1, so there is some updates. We can see some updates are in here, but no route loss. So the route doesn't exist anymore in router 2 and 3. We don't see the route disappearing here, right? We didn't have it in the table. But if I look at the OSPF diff, right, as we continue our investigation and we look at OSPF diff router, and in this case, OSPF database is consistent across every router in the environment. That's part of how OSPF works. We can look at any of them, and we can see that there's an LSA type 5 that's missing from the OSPF database, again, for that route that we were interested in. Here it is, 10.0.128. And so we've used the tool to kind of hone in and figure out what the problem is. And so now we could start to continue our investigation and figure out, well, why did the route for server 3 disappear? And in fact, the next one we might do is say, okay, well, we could run a config check. Did the configuration change? Did we lose interfaces go up and down? And we can drill in. But this, I've been able to do this all from my workstation rather than having to manually SSH into every device, run the show commands, interpret as it goes through.
That's really impressive, Hank. Really, really impressive.
I think so. I think it's awesome. And now that I have an actual network behind me that I manage on a day basis, I've been using these tools to capture baselines of what the known good environment looks like, so that when I do have future network problems, hopefully I don't have any, but if I do, I'll have a baseline to compare to and can start looking for these types of things that pop out as differences.
I mean, I suppose the obvious question, and again, we've run out of time, I think, is like, how does this compare to Ansible or to some of the other frameworks that are out there? But I like this because it's Cisco product, open source product, which is amazing for Cisco products. What I didn't see, Hank, and maybe I missed it, is which types of devices are supported. Is there like a list of routers and switches that Cisco supports? I know there's NX OS and iOS, but do you have a list of supported devices?
Yeah, so it comes down to the operating systems running on them. And so this is very much focused on kind of the routing switching platforms from Cisco. And so iOS, iOS XE, NXOS, iOS XR, those are the main platforms. I'm working right now to actually try to add support for things like the ASA firewalls, right? So we can connect there and learn. And it's a use case I actually have in my environment. And so when I was talking with the team, they're like, yeah, we haven't had a lot of requests for it. And they said, if I give them a list of the first few helpful models and parsers that would be useful for it, they can build that and release it out. So we'll get ASA added to it and other platforms in there. But if I go back, I think I have it open somewhere. Yeah, so if I go in...
Being the cynical network engineer, I mean, one of the problems with all the cool network automation stuff in the past has been that you need to have APIs. But what I like about what you've shown us here is it's simple iOS, but you're getting all this powerful information out just by using the CLI.
Yeah, and that's the one. And you're absolutely right. What's a great piece of this is this does use under the hood CLI connections, because if you think about where I mentioned at the start, pyATS and Genie, these started inside Cisco years ago. I don't know how many years, so I'll throw a BART. Let's say 8 years ago inside of Cisco.
Oh, wow.
And that was before any of those APIs were really starting to move. And so all of the stuff that's in there is all done with CLI. And I just realized we never actually went and looked at any of these. If I go and I look at let me find tests. That's going to be too busy. We'll look at learn here and then console. So this is the way that Genie creates that ops model, the JSON, is that it goes and it runs commands. It ran show interface through CLI. This is the output that the device printed, which should look like a show interface, right? And then it processed all of that data to convert it into the JSON model that we saw. And so it's using CLI just like you would. This one may just be the show interfaces command. I'm scrolling. Nope, it actually ran some other ones. So it ran to learn about the interface status. It ran show interfaces, which makes sense. But it also ran the command show VRF detail, which is a command I don't know if I've ever actually manually ran myself. But under the hood, Genie knew to run that because it had interface details that it could then correlate and connect in. So it ran that command. It also ran show IP interface to get the IP information about the interfaces. And it ran, let's see if it ran anymore. So in here you can see there was an error. It tried to learn, it looked at IPv6. We don't have it enabled, so that didn't go through. and checked on those. So to learn the interfaces on an iOS XE device, or iOS, because it would be basically the same, it ran those commands, pulled them all together. If I go and I look at an example of, where were we, tests, normal, and then to learn OSPF is what I'm looking for. I know a handful of commands to learn the status of OSPF, but I certainly don't know all of the commands off the top of my head. But if I look at the output, what does Genie use when it learns OSPF? Well, it runs show IP OSPF. That makes sense. It runs show IP protocols. That's another one. I know that command, so that makes sense. It ran show running config section router OSPF 1. Okay, that's another one I probably might have ran. It ran, here's one I would definitely not have run, show IP OSPF MPLS traffic engineering link. I wouldn't have ran that one.
No,
right? But it ran it. It ran it and it processed it. Show IP OSPF database router. I think I've ran that command before, but it's certainly not one I would have run in my general like overview looking. But it ran it and it processed all of this data and processed it for me. So that's when we talk about the magic of Genie. It's the knowledge. It's the decades of knowledge from Cisco engineers on what it takes to look at a protocol, all the show commands to gather all of the information, pull that all together, compile it into a single piece of data that you can go through. That's the magic. That's why we call it Genie.
It makes sense. I mean, I think so. The positioning of this tool, I don't know what the right word is. I wouldn't call it a product, but this tool is Python network automation. Is that right? It's different to say DNA Center or something like that.
We kind of put it in. I talk a lot about the tool chest of network automation or net DevOps tools, and the drawer that I put it in the tool chest is my network verification tool. Right? It could be used for configuration, but in general, my go-to use case for this is I want to verify my network is doing what it's supposed to be doing. And traditionally, the way that I verified my network was I tried to ping from one point to the other. And then if that was okay, I crossed my fingers that everything was fine, because diving in and looking at the actual health status of 28 different network features across my entire environment was too much to do on a general basis. But with something like Genie Learn All, now I can let it run, let Genie do it, capture an entire baseline of my entire piece, and then have that as a place to go through. I have an opportunity to truly verify, is my network operating the way that I expect it to?
Yeah, I mean, you've triggered my, sort of, sorry, hang on, I'm going to have to think of the word. So, Hank, you've kind of made me curious now because, Genie, pyATS, do I start with Genie? Do I start with pyATS? You said that Genie is just part of pyATS, so how does that give you something different? And I mean, if you like, we can leave that for another time, but just, you're making me curious now about the differences.
So with the release of Genie CLI, and as I mentioned, this is a brand new release. So we're on the version 19 of pyATS and Genie, their version together, is when we got Genie CLI. With that addition, the place to start is the Genie CLI because it's this easy to use. Under the hood, it's leveraging elements of pyATS for some of the pieces, but you don't have to start there. You can start with the very simple Genie Learn interface, Genie Learn routing, Genie Diff, and we didn't even get into Genie Parse. What Genie Learn does is runs, and we've seen it, it runs all these show commands. Well, the ability to take the output from show IP OSPF database router and turn that into the JSON object, that's called parsing. And so there's Genie Parse, which does that for us. So if I come into my environment, I could run Genie Parse. Let me go here. I can see if I can cheat and do it real quick. So Genie Parse, and we'll say show IP. I got to put it in quotes because it's a command. Show IP OSPF database router, and then I want to run this against the testbed of test beds, and then we'll do this against the normal testbed, and we'll just do it against one. We'll say device router, and you can see how fairly intuitive these commands are too, hopefully. Router, and then I'm going to send this to output to tests quick demo. So it's parsing that, it's running that command and then parsing it as it goes through. And there's some cool features that Genie has under the hood that I'm in the background using for some of these pieces, and for the demos that I've published that other folks can go through that make some of this stuff really cool and interesting to use as well. I'll give you a bit of a teaser at that. This testbed file here, test mock normal.testbed.yaml, it's what we call a mock device. I built that real network, this network that I was showing before. This network, I actually built it in Viral. It's a Viral topology that anybody can stand up. And then I ran the Genie learn command and then recorded the entire output of all of the show commands, the hundreds or thousands of show commands. They were all recorded. And then Genie can actually convert that recording into a simulated device that can take those same show commands and then give you the same output. And what's nice about that is this network isn't alive right now. It's not running. Everything's being driven locally from my laptop. So you could actually clone these down, run these same commands, and you would have access to the same environment, which is why I can say I broke this network in such a way. Because the way that I did it is I went in and I actually broke the network. I ran the Genie learn. I captured every output from that entire piece, and then I was able to build a snapshot of what the network looked like when that feature was broken, and so that I can use that for demos and testing and showing these areas. And up in my code repo that has this piece, and we'll put a link for it as well, I've got, I think, 5 or 6 different broken network situations that have all been captured as part of the repository. And a couple of the demo exercises is I give you like the trouble ticket, and I give you some hints and then say, go find what was broke. What did Hank break in this environment? And you don't need a network for it. It's all been captured in these simulated devices that is just part of what Genie can do by recording and then playing back the output from those commands.
Oh, wow. So, I mean, basically you like building this like copy of the output of a real network, or Viral in this case, and then you've got like that mock network running locally, and you're just running these commands against sort of that captured state.
Exactly. It's so
That's cool.
you can test
cool.
these. They're great for labs if you think about it too, because now I can actually capture a state of a network and then make sure everybody has that and say go troubleshoot it. And though we're using Genie to connect, if you think, Genie's sending CLI commands. And so there's actually a way to start up that mock device and type the show command yourself and see what the output is rather than relying on it. But we'll save that for a later video. Cause,
I was going to say, you're going to have to show me that now. But
we're
out of time.
We are. So let's do this. So I ran the parse, right? So we ran Genie parse. And so the output, the last thing we'll say is I can actually go and look at the parsed structure. So this file here, tests quick demo, which is what I said, show IP OSPF database router parsed. If I look at that file, so it ran show IP OSPF data, the same command, and then turned it into this pit. That's where the kind of the real heavy lifting happens, is all of the development that our engineering team did for all of these show commands, and then how to process that text-based output. Again, the text-based output is this. Right? It processed this string, all of this data, and then turned it into this really nice JSON object that I can drill right into the OSPF database. I can see the LSA types. For LSA type 1, I can see every LSA type 1 that's out there in this nice processed piece. And I think I've said this like 3 times. One more bit of magic. I'm super excited. There's so many cool things in here. If you run... So this command, show IP OSPF database, we ran this on an iOS XE device. There's a similar command to this on NXOS and on iOS XR. I guarantee you the output that comes out from this command is different on those 3 platforms.
Yeah, definitely.
Would you agree, right? The output's different. Genie's additional magic is this parsed body, the way that it's represented after Genie parses it, is exactly the same on all of those platforms. So not only does it take the output and turn it into a structured data, it makes the structured data common across all of those. So I could actually compare the output of, in this case, the OSPF database from an iOS device, an NXOS device, and an iOS XR device. If they were all part of the same area, their LSA databases should be identical. If I learn that with Genie, parse it, and then the objects here should be identical as well. Even though the text output from the commands would be different, the data format, what's built by Genie, is the same. And so I can compare disparate operating systems and see, is the operational status the same? And we focused on operational status, but it does the same thing with some of the config objects that are available as well. Is you could build one version of the config object using the Genie model and then say, hey, go configure this feature, OSPF or HSRP on NXOS, iOS, and XR, and it takes your configuration that was normalized and then turns that into whatever the appropriate config is on those platforms through that standardization that Genie has. One more piece of magic.
So, I mean, Hank, you know, you've introduced us to this amazing tool. Now I want to learn a lot more. Take us back to the site where we get started. I mean, are there examples where guys can like copy, you know, like where you've got, I think it's on your GitHub, you said you've got examples like
It is.
like example, what was that, YAML host file type file, and how you know, is there pieces where we can like kind of copy what you've done?
So the place, and we'll have these links in the video for sure. This up on GitHub, this is the Genie CLI demonstration. That network that we were just looking at going through, this is what I went through that I was talking about. And so this is a great place to start. This will walk you through getting going, preparation steps. You can see if I scroll down a bit, there's that network topology file we were looking at. And I'll just go up here. We can see demo 1, users report problem connecting from server 1 to server 3. That's the one we just talked some of it. We didn't go through the whole demo there. And then here we can see key info. I talk a bit about the test beds and the network devices. Demo 2, occasional network communication issues from server 1 to server 2. So trouble ticket. This comes in. How would we troubleshoot this using the Genie CLI?
Wow. So this is like a whole lab that you've built, is that right?
I did, yeah. It's funny, I was so excited when I got the demo from the team that is behind Genie CLI. They gave me about a 30-minute demo with some other folks, and I got so stoked about it. That next weekend, I built this because I wanted to get it out there and share it with everybody, because it's this really awesome tool to go through. These last 3 demos, server 2 can't communicate with anything, non-optimal traffic patterns, and performance problem. These are captured issues. I built those. I injected those problems into the topology. I captured the state of it, and it's included in the repo. And what those pieces do, if I click on one of these, you'll see it gives you the situation. It gives you like an instruction. Go use Genie Learn, Genie Diff to go figure out what the problem is. And I give you some hints, right? So by the time you get to demo 5, I've walked you through a handful of pieces. My hope is that folks will be able to use these tools to go figure out, what did I inject to make this problem happen, and kind of walk you through. So again, full on lab, ready to use. And it's just up on GitHub.
Yeah, that's great. Wow.
Absolutely.
You've been busy, man. You've been really busy.
It is. I was getting some dirty looks from the wife when I spent a few late nights and stuff in the room, but it was so cool. I just needed to get it like out of my head and into some stuff that folks could take a look at. So. Well,
tell her we say thanks very much. You know, we really appreciate it. I'm sure she won't be that impressed, but thanks.
I don't think so. She loves the passion that's there, so I'll give her that one.
Well, Hank, I mean, I think is that time to wrap it up?
I think it is. We went super long, so we'll see if this turns into one video or 2, or how you break it up. But super exciting tool. I can't wait to hear the feedback from the folks. So please leave comments in the video. Let us know what you think. Reach out on the social medias as always, and I'm sure we will cycle back at some point to dive deeper into some of these other capabilities that are there. Because even with everything we went on in this supersized episode today, we just scratched the surface. There's still so much more to the tool set.
Yeah, Hank, it's just, as always, I want to say thanks very much. You know, appreciate the passion, appreciate you sharing so much with all of us. So thanks very much.